So this is the Jupyter Lab interface. You get to it on a web browser, sometimes by logging into a server on the cloud. And we'll go through how you can get access to one of these servers, or you can install it on your own computer if that's something you want to do. And there's a few things that I should point out on the interface, and if I forget anything, Penny can interrupt me. So on the left-hand side here, we have a bunch of files, and this is actually a computer file system. So I could go into, I can go into different directories, and these are files in a particular folder that I'm running in. And if you want to add files to this, there's a little button here which you can press, and then you can go in and find where they are on the on your file system and upload them. And similarly, when you've done some computational work and you want to download things, you can right-click on one of these files and go to download. But when you launch one of these notebooks, you just do by double-clicking, there you get into this screen. And you can see here I've got a bunch of text just talking about the workshop and Python and so on. And this is one key component of a Jupyter Notebook, is typeset text, and you can add images as well. But the really cool thing, I think, is you can put Python code in there. So I've got one of the most simple Python statements you can write, which just prints you a message out below the cell. And so to run that, I just click in it, I hold down the Shift key, and then I press Enter. And it runs that code. And you can use Python to do all kinds of things. You can use it to do maths. So just written in a very simple sum here, Shift Enter, and it runs it and gives me the answer. But Python on its own is very powerful, but it's quite limited. So we need to bring in more knowledge for Python to use, more instructions for telling it basic things. And one of the packages that's particularly useful for a lot of what we do is called NumPy. This has lots of tools for doing numerical things. And the way we tell Python to go import this code is with this import statement. And throughout these notebooks, I've got these little lines that start with the hash symbol. When the computer sees this, when it's reading things, it tells the computer to stop reading. So you can write anything there. It's a good way of explaining things. So I've tried to add these where I'm explaining lines of code. But one of the things that we're trying to do with VESIcal is make it so you can just ignore all of this, or most of this. You don't need to understand every line of code. And when you come to use it for your own calculations, we've made tons of these notebooks you can download and use yourself. All you need to do is find the bits which hopefully we've labeled saying, this is where your file name goes to the file you want to import, or this is where the number goes to do this particular calculation. You just have to change it. You don't need to write any of this code yourself or understand it. But I've tried to explain it in case you're interested or you want to see what's going on. So I can import all the NumPy functions using that command. And I can now access everything by writing, all of it by writing NP for short. So for example, it now knows how to calculate the natural logarithm of a number. So I can run this cell and we get the answer. And it can do more advanced things. So it can calculate the mean of a set of numbers, for example. So I've put in various numbers here, and the standard deviation of those numbers. And I've had to use this print command again here so that otherwise it will only give you the output from the final line of the cell. So there's all kinds of things you can do. And the final thing to point out here is a very common feature of programming languages, being able to assign numbers to what we call a variable. and it's just a label for a thing that we can put information into. So here, particular relevance to VESIcal is we might want to store CO2 content. So we can say, well, CO2, thing called CO2 is equal to 0.1. And we run that, and we're not asking it for any output, so it doesn't give us any. It's just storing the information you've given it. But then maybe I gave this information to it in CO2 and weight %, but maybe we want to work with parts per million. And so then we can do maths on this, and it will replace the CO2 with that number, and it gives us the answer. And this notation here is short for 1 times 10 to the power of 4. Okay, I think.
Simon, can you quickly show how to make a new markdown in a code cell and just what the markdown cells look like before they've been executed?
Yes. So let's go to the bottom here. I've written some instructions here for how to do this as well, if you want to go back and read it over. And if we want to add a new cell, we go up to this plus sign just here, and we can add hundreds of cells if we want to, if that's useful. And when you generate them, it assumes it's a code cell. So right now I can write something like that, and you see that it's got an empty box there. I run it, and then a number appears when it runs. Now, if I want to write some text in the document, click in this box and go to Markdown, and then I can start writing more things. So I could write hello in Markdown, press Shift Enter, and it transforms into nice text.
Markdown also lets you put LaTeX characters, which can be very helpful. Do you want to do CO2 nicely, or delta or something? So this means you could technically write your entire manuscript in Jupyter Notebook, which is what we think is the future. Me and Simon and
people have done this.
Yeah.
In fact, the VESIcal 1, and I think VESIcal 2 maybe, live in a Jupyter manuscript. You can go in and run, you can create all the figures and calculations within the manuscript itself.